Solving trig equations algebraically, number 68. Here's the question. We have sine squared theta minus cosine squared theta is equal to 1 plus cosine theta. We're supposed to be solving this for theta is less than 2 pi, but greater than or equal to 0. So I'm going to start to solve this thing. And what I noticed, first off, is that I have sine, cosine, and cosine. Because I have cosine more times than I have sine, I think I'm going to solve this in terms of cosine. So what I'm going to do is I'm just looking at this piece right here, and I'm going to get a replacement piece. And we know from our Pythagorean identities that 1 minus cosine squared theta is sine squared theta. So minus cosine squared theta, I'm just rewriting what we already have. Cosine theta. So here I'm going to start to solve. Now this whole thing is in terms of cosine theta, which is really important. So I guess the first thing I'd say is make sure that you have, where possible, your argument in terms of one trigonometric function. So we have that. These parentheses have nothing, there's nothing binding them, so we're going to take them off, and we're going to just gather our like terms. We're going to get 1 minus 2 cosine squared theta is equal to 1 plus cosine theta. Now we're just going to do our algebra, so that's all you have to do here is just do your algebra. I'm going to move everything over. One thing that I want you to keep in mind is that you notice this thing is in the squared form, so it's a quadratic. So when we have quadratics, we solve quadratics. Ax squared, right, plus exactly, plus bx plus c equals 0. So I'm going to put it in that form. And when we get there, when we gather all of our like terms to the left-hand side, we are going to get 2 cosine squared theta plus cosine theta is equal to 0. From here, we're almost done. All we're going to do is a little bit of factoring. We have factors of cosine here and factors of cosine here, so we're going to factor out one term of cosine theta. So cosine theta times 2 cosine theta plus 1 is equal to 0. And now we're just going to solve these things out, right? We're going to use the zero product property. Here, and we're going to say, when does cosine theta equal 0? So cosine theta equals 0. For theta equals what? For theta equals, right, pi halves and 3 pi halves. Solve this one out. When we solve this out algebraically, we get cosine theta is equal to negative 1/2, and we know that's true for theta is equal to 2 pi thirds and 4 pi thirds. And if you're wondering how I got that, I just went onto the unit circle and found those values that matched. So I hope this is really helpful. This stuff is really doable. Just remember to look at this as if it's algebra. To first off, try to get, to the best of your ability, get your function, get your equation in terms of one trigonometric function. So here we had sine and cosine. So we decided, because we had more cosine values than sine values, that we would trade in this sine value for an equivalent cosine value. So, all right, if you haven't already subscribed, please do, and thanks for watching. Oh, comments are always welcome. Thanks.